Friends, back again. We're calculating the pH of a strong base this time. Slightly more complex than calculating the pH of a strong acid, but still not too bad. If I take a strong base, usually people don't like to take strong bases and put them or show the water as part of the equation. Instead, they'll do something like this. They'll put water on top of the arrow to just show that water's present. And when water's present, the strong base ionizes completely into K plus and into OH minus. And just like with the strong acids, we expect 100% ionization. So if I start with 0.65 molar KOH, all of it's going to break up, and you're going to be left with none of the intact KOH at the end. Instead, you're going to end up with some K plus and some OH minus. Now, we know that if we want to calculate pH, we kind of need the H3O plus concentration, and we don't have that here. So what we're really suited to do in this moment is, instead of calculate pH, at least initially, let's calculate pOH. We know that pOH is the negative log of the OH minus concentration. So if I want to calculate the pOH here, it's just going to be the negative log of 0.65 molar. So on my calculator, I'm going to do that. Negative log 0.65, and I get 0.19. So a very low pH. This is a very basic solution. pOH. But here's the truth. We want to know not the pOH. We want to know the pH. And so we learned last time on Friday that pH plus pOH is always equal to 14. So in this case, if I want to find my pH, it's going to be equal to 14 minus 0.19, the pOH, which is going to be equal to 13.8. And that's the pH of a strong base. Here's the only catch. If you look at something like calcium hydroxide in the next problem, when calcium hydroxide breaks up into solution, it breaks up into Ca2 plus and 2OH minus. And it turns out that coefficient is very important. Yes, all of this base will break up. It's a strong base. We're going to be left with none of it intact at the end of the process. But over here, when we gain calcium, we gain 4 times 10 to the minus 3. But for OH minus, it's a little bit different. It's in a 2-to-1 ratio with the initial concentration. So here, we're going to actually gain 2 times 4 times 10 to the minus 3, also known as 8 times 10 to the minus 3. Does that make sense? It's in a 2-to-1 ratio. So now when I go to calculate my pOH, pOH is equal to the negative log of my OH minus concentration, 8 times 10 to the minus 3. And that's equal to, on my calculator, negative log 8 times 10 to the minus 3 is 2.1. So if I want to calculate my pH, it's equal to 14 minus 2.1 or 11.9. And that's the pH of that strong base solution. Okay, let's come back together and we'll talk for a bit.